Hey, in this lesson, we're going to talk about midpoint, distance formula, and Pythagorean theorem. So first thing we need to talk about, we're looking at coordinate geometry, and Miss Swander is here with me. She's hiding out to the side. There she is. She's learning how to do videos as well. When we talk about coordinate geometry, we're looking at two dimensions, horizontal and vertical, x-axis and y-axis. And each point has two coordinates, an x-coordinate and a y-coordinate. Well, as far as the midpoint is concerned, what we have to do is we have to take the average of the two x-coordinates, so x1 plus x2 over 2, and the average of the y-coordinates, y1 plus y2 over 2. And so if we have these 2 points, point A and point B, each point has coordinates, an x-coordinate and a y-coordinate. And what we're trying to do is to find the midpoint of this segment AB. Okay, helpful hint. To make it easier to picture the problem, plot the segment's endpoints on a coordinate plane. I would say if you can draw a picture and that helps you, do it. So let's try a little problem here. Find the coordinates of the midpoint of PQ with endpoints P, negative 8, 3, and Q, negative 2, 7. The key here is to read the problem carefully. It says find the coordinates of the midpoint, and they give you the endpoints. All right, so let's plot this little segment here, and let me do something like this. Here, we'll make it real quick. We're going to do two ends, and we'll make it solid. Okay, we'll do that. And so I'm going to go to negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and then up 3, 1, 2, 3. So I'm going from negative 8, 3 to negative 2, 7. So there's negative 2, 3, 4, 5, 6, 7. So I should be going right there. So here's my segment, PQ. Let me just write that down. Here's P, here's Q. So I need to find the middle of that. Now, we talked before about averaging the points. Something else really important is to assign which point is coordinate 1 and which point is coordinate 2. Now, I generally say whichever one is furthest to the left is coordinate 1. So that would be x1, y1. And whichever one's to the right is coordinate 2. And of course, it has an x and a y coordinate, or whichever point. Now I can go in and I can assign these values. So let's just go ahead straight away and do it. So it says x1 is negative 8, negative 8, x2 is negative 2 plus negative 2 divided by 2, and y1 is 3 plus 7 divided by 2. Negative 8 plus a negative 2 is negative 10 over 2, which is, of course, negative 5, and comma. Again, somewhere I will figure out a better way to write here. 3 plus 7 is 10, positive 10 divided by 2, and that is 5. So the coordinate of the midpoint is negative 5, 5, which would be right smack dab in the middle here. That's M. And the last thing I want to mention here is you'll see that when you average the distance, the horizontal distance is x, right? And you can see that this is 1, 2, 3, 4, 5, 6 units horizontally. So half of that 6, of course, is 3. And the same thing vertically. When you go up, you're going to see this time and time again later in this section, in this video. We're going up 1, 2, 3, 4 units. So half of that vertical rise of 4 is 2. And that's another quick way to determine where your midpoint is. All right, another problem here. M is the midpoint of x, y. Be very careful here because what they're telling you looks a little different. They're giving you the midpoint in this problem. X has coordinates of 2, 7, and M has coordinates of 6, 1. Find the coordinates of y. So this is where you want to be really careful. Go ahead and try this problem, pause the video, and let's see where we get. All right, so here's how I'm going to set up the problem. Again, M is the midpoint. Let me label my points on the graph. Here is point X. That's coordinates of 2 and 7. And M is 6, 1. So if you think about it, if I'm only at the midpoint, let me copy this, and I'm going to paste it, right? Because really, I should end up right about there. So I'm thinking my endpoint, my y coordinate, when I'm all said and done, should roughly be about here. So let's do the math and see how things look. Let me pull this over and see if I can do it in a different way. All right, so let's set this up. So the midpoint of x, right, typically we think of as x1, and I've signed this is x1, y1, and x2, y2 are the coordinates here. I don't know what they are. x, 2, y, 2. I don't know what those coordinates are, so I'm going to set it up. So 2 plus x2 divided by 2 is the midpoint. Same thing for y. The midpoint of y is y1, which is 7, plus y2, I don't know what y2 is, divided by 2. Now, I'm going to substitute the coordinates for the midpoint, 6 for x and 1 for y, right? So I realize you're looking at two things at the same time here, but don't worry, I know you can handle it. And so now that I've got this set up here and here, it's just a matter of algebra. How am I going to get rid of this divided by 2? Well, let's multiply both sides by 2. So what you can see here is I'm multiplying both sides by 2, so really I end up with two separate equations that I have to solve. And then it's a matter of simplifying. 2 equals 2 plus x2, and 2 equals 7 plus y2. Well, the only thing left to do is subtract the constants from both sides. So subtract 2 from both sides, and x2 equals 10. Subtract 7 from both sides, and y2 equals -5. And if you look at this coordinate, it's amazing because this is 10, 1, 2, 3, 4, -5. Amazing stuff, huh? All right, so ruler postulate said you can define distance between 2 points. More practically, when we get into theoretical things, we're going to use either distance formula or Pythagorean theorem. If you don't have the distance formula copied, go ahead and pause the video, make sure you get this in your notes right now, and then we're going to do a sample problem. So here, it says find FG and GK, then determine whether FG is congruent to GK. So we need to find the distances of each one. If you want to pause the video and try it right now before I explain it, go right ahead. Okay, let's see how you did. Now, it's important when you're taking the length of each one of these segments that you have a coordinate 1, x1, y1, and a coordinate 2 for each segment. So it's like you just get layers of complexity building on one another. So let's take a look, because I said, again, of each segment, the lefternmost point has the coordinates of 1, x1, y1, and the rightmost of each segment is coordinates number 2. And you'll see that here as I open it up. Okay, so the length of JK, and I'm substituting, right, the coordinates x2, right, x2 is -1, x1 is -4, right, and then y2 is -3, y1 is 0, into the distance formula. And then it's a matter of simplifying. Again, you can't have a negative length, so when we square these values, they're naturally going to come up positive. So the length of JK is the square root of 18, which is 4 squared is 16, 5 squared is 25, so it's between 4 and 5 units long. Now do the same exact process for FG. Now if you didn't do JK correctly, go ahead, pause now and redo FG. All right, welcome back. Let's see how you did. So again, the same setup using the distance formula. I'm substituting the coordinates. It will work either way so long as you do it consistently across. So I've got 5 minus 1 squared plus 5 minus 2 squared. And I get the length of FG is the square root of 25, or 5. But I do know, determine whether these two are congruent. They are not. So that is a really lengthy way to find the length of two segments. A much easier and faster way is using the Pythagorean theorem, which is a squared plus b squared equals c squared. I'll show you. Let me just go back a moment and take a look at this. If you look at this vertical distance, you say, oh, okay, well, that's 3 units. And if you look at the horizontal distance, that's 3 units. So 3 squared and 3 squared. And that's where these values are coming from. If you compare that to FG, well, wait a minute, from F to G horizontally is 4 units. And that is 3 units. So wait, that's 4 squared is 16. That's 3 squared is 9. That's where this 25 is coming from. So just using the Pythagorean theorem, you get the same result as the distance formula, although it's much easier once you have a picture. If you don't have a picture, it's not easier to do. But once you have a picture, then you can just look at it and figure out what the horizontal and vertical distance is, square each, and then take the square root of their sum. So in a right triangle, right, you're using the two sides, which are called legs, to determine the distance of the hypotenuse, or any two of those three. If you're given a leg and the hypotenuse, you can find the other leg. And that's what we're looking at here. Side A, denoted with a lowercase a, side B, with lowercase b, those are legs, and side C is always the hypotenuse. Repeat, side C is always the hypotenuse. We're going to study this a lot, and but it's a really nice, easy trick for finding the distance on a right triangle. Now here's a real practical example. I want you to try this problem now, and the biggest challenge is how do you plot it? Once you get it plotted, then you've got a right triangle and it's easy math. So go ahead, pause the video, see how you do. All right, here's Mr. Rising's take on this problem. A player throws the ball from first base. So let's start at first base. If you don't know baseball, this problem is completely irrelevant. But if you do know baseball, this is first base. From first base to a point located between third base, here's third base, and home plate, 10 feet from third base. Well, each one of these units is 10 feet. 10, 20, 30, 40, 50, 60, 70, 80, 90. So each unit's 10. So between these two, 10 feet from third is right there. Wait a minute. I still have a right triangle. What is the distance of the throw? It says to the nearest tenth, which means we're not going to leave it as a radical. Well, let's just, how far is it? So wait a minute, right here. Get out the old red marker. I know this is a right triangle. I've got leg here. What is the length from home plate to first base? Of course, you're shouting, Mr. Rising. I know this. Would you please speed it up? No, I'm going to write it out anyways. This is 90 feet. Well, how far is it from home to a place 10 feet short of third? Well, of course, that's 80 feet. 80 feet. So again, I'm sorry I'm using this marker. Actually, let me pause and type it out. All right, let's see how you did. 90 feet to first base, side A. 80 feet to that point 10 feet from third base is side B. Let's use the Pythagorean theorem. A squared plus b squared equals c squared. Well, 90 squared plus 80 squared is c squared, the distance of the throw. 8100 plus 6400 is c squared. Combine those two, you get 14,500 feet equals c squared. Now, how do we solve that? Of course, you're jumping out of your seat saying, Mr. Rising, you just take the square root of both sides. Of course you do. That's exactly what you do. And you get 120.4159, and it goes on and goes on. But the question says, what is the distance of the throw to the nearest tenth of a foot? So really, we're going to cut off the problem here, but we need to look at this digit, the hundredths place, to see if we're going to round up or leave it the way it is. Since it's a 1, we're just going to keep it the same. So the distance to the nearest tenth is 120.4 feet. That's all we're going to do for today. Hope you feel much more comfortable with midpoint formula, distance formula, and Pythagorean theorem. We'll practice this more in class, specifically when you're looking for an endpoint or the midpoint. That tends to be the most confusing part of all.